April 17, 1943. Bethlehem Steel Shipyard, Pennsylvania. The night sky glowed orange as molten metal poured like liquid fire into waiting molds. The air trembled with the hum of overhead cranes, the clang of hammers, and the deep roar of blast furnaces. The war demanded steel, and this place had become an inferno of creation ships. Guns, armor all forged in sleepless rhythm. Inside Building 29, the heat was suffocating. Sweat rolled down the faces of welders and machinists working beneath the sparks. The sound of metal grinding on metal filled the air. But above it all stood a man staring at a blueprint, jaw clenched and hands blackened with soot. Charles Van Every, a naval engineer barely past 40, was supposed to be the man who could do the impossible. Behind him, a supervisor shouted over the roar. Another delay from the gun foundry. The 16-inch barrels are behind schedule again. Van Every turned slowly, his eyes narrowing. The 16-inch naval gun, the very heart of America's battleships, was a monster of engineering. Each barrel stretched nearly 66 feet long and weighed over 200,000 pounds. Forging one required precision, patience, and months of furnace time. But the Navy wanted dozens, and they wanted them yesterday. 3 months, the supervisor continued, waving a clipboard. That's what it takes, just to cool one blank before machining even starts. Months. At this rate, we'll be lucky to arm the Iowa before Christmas. Van Every didn't reply. He was watching the furnaces, his mind running faster than the machinery around him. Months. It always came down to months. Cooling, boring, rifling each step, chained to the slow rhythm of metallurgy. But what if he thought it didn't have to be? He leaned over the drafting table and began sketching something radical. A segmented gun barrel. Instead of forging the entire 16-inch monster from one solid block of steel, he imagined breaking it into modular sections, individual rings and sleeves that could be cast, cooled and machined separately, then assembled like the bones of a giant mechanical beast. An assistant glanced over his shoulder. "That'll never hold pressure," he muttered. "You're talking 50,000 pounds per square inch in those chambers." Van Every didn't look up. "It'll hold," he said quietly. "If the tolerances are perfect, and if we heat bond the segments under compression, we don't need one piece of steel. We need one system of steel." The assistant frowned. "Double quote, sir. Nobody's done that. Not for a main battery gun. We'll be the first," Van Every replied. He folded the sketch, grabbed his helmet, and headed toward the forge floor. The factory was a cathedral of light and noise, steam hissing, gears grinding, molten metal glowing, brighter than the sun. The men looked up as he crossed the floor, his boots clanging on the steel grating. "Gentlemen," he shouted over the din, "we're going to try something different." He laid out his plan. Simultaneous casting of multiple barrel segments, using precision molds, pre-stressed shrink fitting to align the pieces, and an inner liner that could be swapped out for maintenance. The crew stared, uncertain whether to laugh or salute. "Sir," one machinist said, "that's not engineering, that's madness." Van Every smiled faintly. "Maybe, but if it works, we'll build a battleship gun in 15 days. Silence. Then someone chuckled nervously. Another cursed under his breath. Yet, in that moment, beneath the blistering glow of the forge, something changed. Doubt turned to curiosity. Curiosity to resolve. The first molds were poured that night. The liquid metal hissed as it met the steel molds, releasing clouds of glowing steam. Men worked through the night, hands trembling, hearts pounding. Every step was untested. Every reading mattered. At 2:37 a.m., the first segment cooled without cracking. A small victory, but one that drew cheers across the floor. Van Every didn't smile. He only said, 9 more to go. Above the noise, the factory clock ticked toward morning. The war outside raged on, but in this blistering chamber of fire and iron, something revolutionary had begun, an idea so bold that even the skeptics would soon have to believe. April 20th, 1943. 3 days later, Bethlehem Steel testing range. The morning mist clung to the Pennsylvania hills as a small convoy of trucks rumbled toward a fenced-off testing field. Crates, marked U.S. Navy Ordnance Division, rattled in the back, guarded by MPs and mechanics who hadn't slept in days. Inside, one of the crates lay the proof, the failure of Charles Van Every's radical idea. The first modular, 16-inch gun barrel ever built. Van Every stood beside the test rig, coat flapping in the cold wind, his face drawn but alert. Around him gathered a crowd of officers and engineersmen from the Bureau of Ordnance, skeptics all. Among them was Commander Robert Willis, a veteran naval inspector with a reputation for shredding half-baked proposals. Willis took one look at the segmented barrel and frowned. "You're telling me this thing's made of 10 pieces, bolted and heat-shrunk together, like a toy cannon?" Van Every nodded. Each ring was precision-cast, cooled, and stress-tested. Individually, the liner was inserted at 1,200 degrees and sealed under pressure. "It's one barrel now," Willis snorted, "until the first round blows it apart." Technicians were already hauling the gun into position at 25-foot test fixture that looked like a Frankenstein monster of steel beams and cables. A Navy ordnance officer called out the readiness checks. Pressure line clear, breech locked, live round loaded. Everyone stepped back. The range went silent except for the ticking of the pressure gauges. Then, a deep mechanical thunk echoed across the field as the firing pin slammed forward. The explosion tore through the air like thunder. The ground shook. Birds erupted from the trees. A column of smoke and dust shot skyward and then slowly drifted away. When it cleared, the gun was still there, intact, not a single crack. Van Every exhaled slowly. Technicians ran forward, shouting readings. Barrel temperature stable. Chamber pressure within limit. No deformation at the seams. Commander Willis approached the gun, running his hand along the steel where the segments met. "You're telling me this thing held together at full charge?" "Yes, sir," Van Every replied. 15-inch projectile, full powder load. Willis looked him over, then smirked. "I'll be damned." By noon, word spread across the shipyard. The impossible gun had fired and survived. Workers who'd once mocked the crazy engineer now watched him with new respect. The Navy ordered a second test, then a third, and a fourth. Each time, the segmented barrel performed flawlessly. Soon, the Bureau of Ordnance issued an urgent telegram. Greater than begin mass production of modular 16-inch barrels. Prioritize Iowaka-class requirements. Time frame -15 days per unit. Confirm readiness. For the first time, Bethlehem's furnaces ran ahead of schedule. Crews no longer waited months for massive single ingots to cool. Now, smaller sections could be cast in parallel, machined while others were poured, then fitted together in perfect sequence. It wasn't just faster, it was smarter. The modular process meant less waste, lower stress on materials, and easier replacement of worn sections. By May 1943, the first fully operational modular gun was installed aboard the USS Missouri, still in dry dock. As the crane lowered it into place, workers cheered. Van Every stood at the edge of the dock, his hands clasped behind his back, watching the barrel slide home into its turret cradle. "You just rewrote the rule book," the shipyard superintendent told him. Van Every gave a faint smile. "No," he said, "the war rewrote it for us. I just learned to read faster." The Navy sent a commendation, but Van Every didn't keep it. He sent it to the forge foreman, the man who'd once called his plan madness. By summer's end, production times for the great naval guns had dropped from 200 days to just 15. Battleships like Iowa and New Jersey left port armed and ready, months ahead of schedule. But the innovation carried more than speed, it carried a message. To every enemy commander tracking America's industrial capacity. It was proof that the U.S. war machine could adapt faster than anyone imagined. Still, Van Every knew the system wasn't perfect. He'd pushed steel beyond its known limits, and somewhere deep in his mind, he wondered what happens when the war ends and there's no more need for miracles. That question would come sooner than he expected. June 1943. Norfolk Naval Base, Virginia. The sun shimmered off the gleaming hull of the USS Missouri, her decks alive with welders, riggers, and engineers rushing to ready her for sea trials. The ship's heart now beat with a new rhythm. 3 massive 16-inch gun turrets, each crowned with barrels, born from Charles Van Every's modular miracle. The Navy's top brass had flown in to see them tested. The crowd gathered on the pier was a sea of khaki and dress blues. Admiral Chester Nimitz himself stood near the railing, his cap casting a shadow over his eyes as he studied the monstrous cannons that could hurl a 2,700-pound shell 20 miles through the air. Van Every stood beside Commander Willis, clipboard in hand. His hair was thinner, his face more lined, but his eyes burned with the same fierce curiosity that had carried him through sleepless nights and molten storms. "Do you ever get used to that sound?" Willis asked quietly as the first gun's breech slammed shut. Van Every smiled faintly. "No, you don't get used to thunder." A red flag rose on the dock. Gunnery officer shouted the firing command. The crowd fell silent. Battery, fire. The detonation tore through the morning like the wrath of a god. The Missouri shuddered, waves rippling outward from her hull. The concussion slammed into the crowd like a physical force. Then came the distant roar as the shell arced over the Atlantic horizon. When the smoke cleared, the barrels gleamed, unbroken, steady, and perfect. A chorus of cheers erupted from the pier. Nimitz clapped his hands once, then turned to Van Every. 15 days, he asked. 15 days, Admiral, from mold to mount." The Admiral nodded slowly. Then, "God help anyone on the wrong side of these guns." The modular process didn't just change one ship. It transformed the entire wartime supply chain. Shipyards that once waited on bottlenecks from foundries now operated in overlapping cycles. Crews trained to assemble the barrels like clockwork, cutting months off delivery times. By late 1943, the system was adapted for 8-inch cruiser guns and 5-inch dual-purpose mounts. Spreading across the fleet, engineers from Britain and Canada toured the facilities, taking notes. Even the Soviets, through Lend-Lease correspondence, inquired about the technique, though the US Navy never shared the full details. But for all the celebration, Van Every remained uneasy. He knew that what made his process possible wasn't just ingenuity, it was desperation. Every shortcut, every untested method had been driven by the brutal math of war. More ships, more guns, more steel, faster than ever before. The system worked because failure wasn't an option. That night, long after the tests ended and the dignitaries had departed, Van Every walked the quiet length of the dock. The Missouri loomed above him, her guns pointed toward the dark horizon. He rested a hand on the cold steel. 15 days, he whispered, but at what cost? Behind him, a young engineer approached, one of his apprentices, wide-eyed and proud. "Sir, the Bureau wants to name the new process after you, the Van Every method." He shook his head. "Don't name it after me. Name it after the men who poured the steel, who worked the night shifts. They're the reason it worked." The young man hesitated. "Sir, do you think we'll ever need to build them that fast again?" Van Every looked out toward the dark ocean, where somewhere far beyond, the war still raged, carriers burning in the Pacific, destroyers locked in convoy battles across the Atlantic. He said quietly, "If we do, it means the world didn't learn a thing." As the months passed, Van Every's innovation became one of countless unsung victories in America's vast industrial miracle. The Iowa-class battleships would go on to bombard enemy shores, from the Marshall Islands to Okinawa, their guns speaking with the voice of Van Every's 15-day revolution. When the war finally ended, the foundries fell silent. The furnaces cooled. The same men who'd worked by firelight now went home to quiet towns and peacetime jobs. But in the archives of naval engineering, one entry stood out. Modular, heavy gun construction, 1943. Charles Van Every, Bethlehem Steel. A footnote, perhaps in the grand machinery of history. But for those who'd seen it happen, who'd watched molten metal turn into power, an impossibility turn into victory, It was proof of something deeper, that in the darkest moments of war, human ingenuity burns brightest.